Welcome back to another video on speech processing. In this video, we will look at advanced speech applications. And some of the slides come from Jeff Adams at Cobalt. Jeff Adams is a BYU alum. I've mentioned him before. He's a BYU alum who is an innovator and researcher and entrepreneur in the speech processing and synthesis space. He is the CEO of Cobalt Speech management team. Yeah, Jeff Adams. And they just hired a grad, a BYU grad who did our undergrad linguistics and went to the University of Washington to do their computational linguistic master's program in speech processing, I think. Anyway, they just hired him recently. So let's go back here. And aren't all applications of speech processing advanced? Well, we're talking more than just ASR and TTS. We're talking about more modalities like signing and gesture and lips. And we're talking about more domain knowledge and general knowledge about the world and history, as well as more than one language. Here's a recent call for a conference in speech processing, SPLAT. I think that's speech processing, language, assistive technology. I'm not sure about the acronym. You can see just looking at the call for papers here for this conference, speech synthesis for physical, cognitive, and sensory impairment, sign synthesis, sign language automation, all sorts of stuff in here. Silent speech, like we mentioned in a previous lecture, brain-computer interfaces for language processing applications. Anyway, so this field of speech processing and synthesis is really advancing quickly. One application is rich transcript, which is the idea that you have a bunch of people talking into the same microphone or the same conference call device, or an omnidirectional microphone like this thing. You could turn into omnidirectional, right? Set to omnidirectional. And you want it to, number one, transcribe what each person is saying and identify each person as a separate speaker, and also do the voice activity detection, the VAD that we've done in speaker diarization, separating out the different voices from each other, and then do ASR transcription, but also try and figure out dynamics like hierarchical relationships in the group, like who's the boss, who are the underlings, what the goals and agenda are, how far each speaker is from the microphone, any emotions or speech acts or non-literal uses of language like metaphorical or sarcasm. Right, trying to do all that is tough. And there's been a competition hosted by NIST, the National Institute of Standards and Technologies, for years. Let's see if I have that up already. Sorry, real quick, let me jump out here. Did I still have that up from when I looked at it? Let me just Google it again real quick. NIST, rich transcription. Yeah, this one. Rich transcription evaluation. They have a competition that they host to try and improve the state of rich transcription systems. Other TTS applications, there's this website called Korean Accented English Pronunciation System that you would give it. Native English speaker would speak, and they would turn into Korean accented pronunciation. The person who created that for her dissertation got a job with the government, and they asked her to take it down, so it no longer exists. But also voice cloning. There's some really interesting examples here where you have a sample of someone's voice, and then you can synthesize the voice to say other things. And you can even create new voices. So here's some examples with Tacotron. So here's the reference. Let's just listen to this.
The Norsemen considered the rainbow as a bridge over which the gods passed from Earth to their home in the sky.
So that was a real person speaking and recorded 5-second or 4-second snippet. And then this stuff down here is a synthesized version of her voice. And she did not say these next things I'm going to play.
Take a look at these pages for Crooked Creek Drive.
It's pretty darn good. Here's the next one down. She's going to say this sentence right here.
There are several listings for gas station.
Again, she didn't say that. They just recorded this.
The Norsemen considered the rainbow as a bridge over which the gods passed.
And then synthesized using her voice to say the other things. Really cool. Lip reading is a big field of research in speech processing, seeing someone's lips and trying to figure out what they're saying. This might be useful in I don't know, airports or train stations or something, perhaps. And you're replacing the missing audio with subtitles. So based on the lips, you create a transcript of what was likely said. And it's now better than humans. And here's a video. This is a presentation given by...
Okay, let's bring this puppy home. This is the last presentation. And it is sort of like that, and with increased rate.
Anyway, he's talking about his system.
And that is, I mean, we've talked about, and with this,
deep
very, very
neural network stuff. Anyway, you can take a look at that if you like. Lip reading is another big advanced application of speech processing. And lip syncing is really fascinating here. Being able to not only create, like it's modifying the actual images. So it's doing lip generation. It's modifying the mouth and the lips and creating speech to go with it. Here's a paper, a recent paper about the dual lip system that was created by these researchers at Microsoft and two universities, or one university, it looks like in China, if I'm not mistaken. This right here, this wave to lip, is really interesting. It's a deep fake wave to lip here, accurately lip syncing videos in the wild. And they have interactive demo. They have the Colab notebooks here. Let me just do the interactive demo. Let me demo this website for you, how to put together some audio with video. So here's a video I created. Let's just watch it. Let me zoom in. Here we go. My name is Earl Kerr Brown, and I teach linguistics at BYU. Okay, so that is the video I created. Then I have some audio that I created in Audacity, which I'll show you in Audacity. Actually, here it is. Once upon a time, in a faraway place. So I have the classic opening to a fairy tale in our culture, right? And then I had this software take that audio and put it on my video and actually move my lips. It's controlling my lips in the video itself. Now they have a water print thing there because it's a free demo, but try and look at my mouth here. Once upon a time, in a faraway place. So it's not perfect. There's a little bit of unnaturalness there, but it's kind of cool that they're moving my lips. They're modifying the video to have it in sync with what I give them in the audio. So that's cool. It's a deep fake lip syncing thing. All right. Yeah, more deep fake stuff here. Again, with the idea of of synthesizing someone's voice using their own voice. So here's a video about
and it
Presidents
performed
of
incredible.
the United States.
By this, they were not heard in the original.
The President of the United States is the head of state and head of government of the United States.
So what they've done for these four presidents, they have they're moving the lips to that audio. Obviously, the audio is someone else, but they're changing the video to mimic the audio. There's some other examples here. Take a look at those. Let's see if I need to, do I want to show any of these? I'll let you take a look at those on your own time. Oh, there's a gesture synthesis as well, like actually
giving
moving
input audio, moving, produce following video.
Hands and arms.
Look, we all know we've come through some hard economic times,
Tilts
and we've seen some
bit.
pretty big changes. But I believe in our people. I love
There's a
this.
little bit of a natural movement, like of her shoulders when she's moving her arm. Like so, the synthesizer is moving her arms. So it's gesture synthesis here. It's taking this audio, and you can see a little bit of unnatural movement of her shoulders, especially.
And I'm convinced our best days are still ahead of us if we
read the arms. Anyway, so that's gesture synthesis there. Also doing ASR recognition of code switching, right? Code switching is a reality of many people in the world having two different languages that they use in different contexts. Like at home, they may speak Spanish in the US, but out in public and schools, they speak English, or even code switch on the fly with family members at home using both Spanish and English. That's a reality for millions of Americans who are born and raised in a Spanish-speaking home, Spanish-speaking family, or English in Hindi, or Urdu in India, or Ukrainian and Russian in Ukraine, or Swedish and Finnish in Finland. So having an ASR system that can tell, it has to do language detection, language identification, that is, like every utterance to make sure that they're still speaking the same language they just were a second ago. If not, then you have to change to another model, have these different models being ready to do ASR. So that is another advanced application of speech recognition systems. Question and answer, like I mentioned in a previous lecture, is here's Ken Jennings, one of the best Jeopardy players of all time, and a BYU alum. And what is it? Well, it's natural language understanding and generation, a response to retrieve from some data or knowledge source, right? It's used to answer many types of questions, factoid or named entities or document summary or snippets. This is the text retrieval, evaluation, something Q&A competition. And so that's a big advanced application of ASR as well as TTS. I showed you a couple examples here in the previous lecture, but I'll just show you one here as well.
We're going to, gentlemen.
Right in here, the excavation of this city mentioned in Joshua showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400.
Anyway, I'll let you watch that if you like. There's Ken Jennings and another champion of Jeopardy, Brad. So yeah, they're trying to model and simulate and then beat experts. They're beating humans. Whether or not the robot, the computer knows more answers or just simply is better at the timing it, like the clicking in at the right millisecond, I'm not sure. This graph here on the bottom left of the screen, right, you have a XY plot here. On the X, we have percent of questions answered by these different participants, and the precision is how many of the answers that they gave were correct. Obviously, you want the champions are way up here where they answer a lot and almost all their answers are correct, right? And so Watson, IBM's Watson system beat out all the humans. And you have this on the top right of the screen. You have all these components that go into it, and you have these candidate answers, and then you have to score the candidate answers and then get a confidence interval. And that's what we saw in that video a second ago. Let me just go back there real quick. Right there, you see these percentages in the bottom. Well, I'm covering up. Let me remove myself for a second. These down here, these are like percentages of confidence of these answers that Watson thought about the answers. Jericho is the top by far, right? Okay. Speech translation is another advanced application of speech processing, speech synthesis. It's kind of like automating the fire hose. It's trying to get in, trying to understand, and so there's a lot of technologies these days, a lot of apps like I have here on my iPhone, right? The Translate. If I just say something let me just say something. I wonder how well this thing works and if it works well. And I'll have it say in Spanish.
Me pregunto qué tan bien funciona esto y si funciona bien.
They have a Spaniard synthesized voice there, but anyway, yeah. So that's an advanced application. That there's a lot of systems out there. There are the systems. Let me jump back. We'll get to that in a second. But for humans to do interpretation, there's a lot going on. It's super cognitively demanding. I've done simultaneous interpretation, that is, simultaneous interpretation of spoken English into spoken Spanish, just as a volunteer in the church and in a previous stake that I was in. And it's super cognitively demanding to do all this stuff. Understand the speaker, understand the domain vocabulary, understand the hearer's context, translate into the target language, speak the target language message, communicate content, emotions, try and emote, not just simply get the words across, but try and emote what the emotions you're hearing are. You have to be fluent in two languages. Usually go from your L2 to your L1. The best way is to go from your L2 into your L1 because you have more control of your L1, right? And so you have more dexterity with creating the right emotion or the right meaning. And you're using two languages simultaneously. You have to hear and understand and talk at the same time, super cognitively demanding simultaneous interpretation. Nerves of steel. There was one time when there were three of us in the stake that were interpreting for a meeting, and we would take breaks because, again, it's super cognitively demanding. And there's one time I just had to stop right in the middle. I was like, I can't do it anymore. And I just handed the mic over to the next guy. Like, I can't, my brain is now exhausted. I can't do it anymore. Anyway, so with speech applications, right, it's basically speech to text, ASR, right? And then we do some type of correction, and then we do machine translation under the hood, right? The good old-fashioned, new, cool, exciting, shiny machine translation. And then we do TTS out, right? That's what's happening there with speech translation. Here's some products. These links may be, I apologize, these links may be dead. But you can find samples of these, this type of technology, and I apologize if you stumble onto anything inappropriate. Please let me know so I can update this. But there are some links to some there. What are challenges of speech-to-speech translation? Well, modeling interpreters, right? Incremental, interleaved language processing. Again, so that's listening and speaking at the same time. Also trying to escape the sentential straitjacket. That is, you usually don't interpret just sentence by sentence, right? And so trying to get a good quality translation or interpretation should not worry about sentence boundaries. Sometimes it's best to not, combine two sentences or break the source sentence into two, perhaps. Real-time performance. There are specialized domains. I have a friend who works as a professor of interpretation, and he was going to interpret at a conference in Spanish. He's a native English speaker, BYU alum as well, and he had to learn how to talk about the strength of textiles and fibers, and he had to talk about like tensor. What's the word for strength of fibers? I can't remember the word right now. And neural systems are the way to do that these days, but there's a paucity or scarcity or lack of good training data, interpretation data. Often because the interpreters, still make mistakes. Humans still make mistakes as they're interpreting. They don't want that to be on record. Sometimes they don't want their recorded materials to be used in training. That could be one problem with trying to get training data for these type of systems. How about medical dictation? Here is dictation that a medical professional made about a patient that he or she had contact with. Okay, so that can be useful. Specialized ASR systems and being trained on medical terminology so that it gets all the terminology correct, like bilateral knees and mediolateral, right? X-rays. What is this word? Patellofemoral crep. I'm not even trying to say that, but there's a word that, you got to have an ASR system trained on medical stuff to get that right. And doing punctuation correctly and doing some inferred sections. Like it seems like this is talking about medical history here, and this talks about medications, and this is allergies, and having a system be able to do that type of like organizing the dry transcription into those kind of nicely organized sections is an important step. Okay, so now what I'm going to do is I'm going to break out of this slide deck. When I put this up to Google Slides, it was like 257 megabytes because of all these next pictures that I'm going to show from Jeff Adams. So I'm going to break out of this slideshow that I have on Google Slides and jump over to this one that's on my hard drive, where he has supplied. Oh, it's going to do that view. Is that the view it's going to do? Let me see on OBS. Oh no, it's not going to do that view. Okay. I'm just going to click through a bunch of pictures here of different applications of speech processing applications. So assistants, right? Let me get back over to this point. So assistants, right? Those are now somewhat commonplace, since the last, 5+ years, maybe even up to 10 years at this point. How about an assistant for farmers who need to use both hands, while they're working, but need to maybe take notes or note things? How about an assistant for a voice assistant for a complex factory machine, having a voice to help the person use the machine? How about an assistant for the elderly or the homebound? That's kind of like an Alexa type thing, but specifically for the elderly and the homebound. How about a shopping concierge, or like a reference desk in a store that you can walk up and interact with a voice assistant to say, hey, where are the shoes for men? 4th floor, perhaps, out above. How about an assistant for a medical medic, army medic, that is, who has to use both hands, working on someone, but a team of people, and they may not have all the information on what to do, and having a voice assistant that's trained to help them with that situation can be useful. How about different interfaces? How about a hands-free control for surgical equipment? How about a voice interface for warehouse pickers who are filling orders, like on some online orders or something, to have a voice assistant there to help them. A voice interface for home security, a voice interface for cars. That's, a thing already. Voice interaction with ads, right? So there's a class here right at BYU, CS 471, that is about voice interfaces. How about entertainers, interactive games and stories, interactive toys like for autistic kids like we mentioned before. How about different coaches? A post-operation coach, like to make sure you're taking your medicine after operation or doing your exercises or whatever needs to happen. How about a public speaking coach that can give you feedback? Language learning coaches, those are common, right? Duolingo and Babbel. Special needs coaches as well. How about a running coach or a companion? Rather than just listening to music, having like some type of interaction with a voice, agent or running coach. How about some monitors? Order taker monitor, call center monitor, making sure things are going well, corporate hosted media monitor, monitoring media for compliance and intelligence. How about appliances, like voice enabled stuff like a fridge or other stuff? How about kind of guards, like voice print for banking apps, using your voice as like a two-way authentication to make sure it's the person who claims to be. About voice prints for home security systems, right? How about detectives? How about a fatigue detector? Perhaps you can create a system that detects fatigue in the voice. How about an acoustic event detection, like a broken glass, a broken window in a home as part of a security system, or like gunshots in a central part of a city? Detector in the voice of various diseases, that can be useful. About different types of scribes, right? We talked about one previously, the rich transcription. Courtroom transcriber, a meeting transcriber, like we talked about, rich transcription. Voice transcriber already is a thing and does a good job. How about a lecture transcriber and indexer? There's a medical transcriber technology that we've already seen. Documenters. How about a construction inspection documenter, like somebody who goes and inspects the construction site to make sure things are going according to code of the city? Or an agricultural documenter who needs to use both hands and is looking for bugs on his plants, for example, and can just kind of make notes or transcribe what he's seeing rather than having to like stop and write things down on a tablet or a piece of paper. Hospitality, housekeeping reporter, like, there's a missing towel in room 413 and there's a stain on the carpet, something like that, where they can be more effective, more efficient just by talking while they're working rather than having to stop and write things down. How about an enabler? Telemedicine and telepresence robots, interactive voice translators, like I just gave you a demo with my iPhone. Caption phone systems for the hard of hearing who can't hear very well. They want to see what's being said on the phone system. Automators like unmanned autonomous vehicles for air traffic control purposes, or an emergency tractor shutoff. If somebody's, gets caught up in some machinery, they can just like yell or scream or say some command to have the tractor stop. So anyway, there's quite a few categories of possible advanced applications of ASR systems. So let's jump back to this view. There's quite a few applications out there. I fear that this is already dated. This field is moving so quickly that it's hard to keep up. So there you go. There's some advanced applications of speech processing and speech synthesis. See you next time.